Can I wrap? Hello, can I wrap?
With sir.
The consequences. I told you why that happened. Because every proton which is being added along with the electron is supposed to neutralize the positive charge, but as the electrons are far away from the nucleus, the positive charge in true sense is not being neutralized. So gradually the excess positive charge builds in the nucleus, by which all the orbitals are being pulled inside. We'll see the consequences of lengthened contraction. It's very important. I don't know whether you'll be able to see it or not. Things are not that clear. I'll bring it here. See here. This is the first series. Here, F orbital does not start. This is of the second series. After this series, the 4F starts. See, we know when you go down the group, the atomic radii increases. So in this case, you will find the atomic radii of the second series of d block elements are bigger than the or larger than the first series. But when you go to the third series, this one, you will find it very strange. The atomic radii are almost same or smaller than the second series. We know that we have read into periodic table. When you go down the group, sizes of the atoms or ions increases because you add extra shells. Here also extra shells are being added, but you find is almost same or smaller than the previous one. This happens because of the lengthened contraction. So now here. Resemblance of why? Because after second series, the F4F, before you go to the third series, you fill up 14 electrons in the F orbitals. So much of the nuclear charge is being developed because of the incompetence of the 4F electrons to neutralize it. So the orbitals, all orbitals are being pulled inside. Okay. So right now here, due to the lengthened contraction, the elements of second each other more closely.
Sir, I cannot see anything.
You can't see anything.
Yes, sir, my connection is very poor.
Then what to do? Okay, you write down whatever I have written. I'm telling you. Please write.
Okay, sir.
Resemblance of second transition. Resemblance of second transition and third transition series elements.
Done, sir.
Right. Due to lengthanoid contraction. Put a comma. The elements of second and third series the elements of second and third series transition elements resemble each other more closely than the elements of first and second series. For example, the atomic radius of zirconium for example, the atomic radius of zirconium, within bracket you write 160 picometer, PM, is almost identical. We'll write. Atomic radius of zirconium of second series. Second series is almost identical with third series hafnium. And this is 69 picometer. Hence,
Sir, 150, sir.
huh?
150 picometer, sir.
Zirconium is 160 picometer and hafnium is 159 picometer. Where it is 150?
No, sir. I saw that as 150. That's why.
Oh, no, 115 picometer. Hence, both of them exhibit identical hence both of them exhibit identical behavior. Occur together in nature and is difficult to separate from each other. This question is very important. This is very important for your exam. They'll ask you why it is difficult to separate zirconium from hafnium. So you'll write due to lengthened contraction, they have almost identical atomic radii, hence they show similar properties and difficult to separate. Resemblance among it is when you go through the series, initially we have discussed about the similarity and property of the second series and third series. Now we are comparing the property among them. So due to lengthened contraction, a very small difference is there between the atomic radii. Because of that, they also show the same property. Due to lengthened contraction, the change in the ionic radii in the Lanthanoid series. Is very small. And so their chemical properties are similar. Because of that, because of this, it is difficult to separate these elements in pure state. Okay, I'll tell you now how by normal process, whatever you do for other metals, we cannot do it in lanthanides. So what do you do? So I'll write now here. This for your entrance exam. Or maybe CBSE exam also. No. Lanthanide mixtures are isolated from each other by chromatographic method. Please remember. By normal process, you cannot separate them.
Sir.
Then third, basic strength of hydroxides. See, I tell you, suppose you have taken an anion, okay? Anion is small and cation is also small size. And you have taken a small cation and anion of large size. See here, very interesting thing. Then you have taken a large cation an anion of small size. See, cation has, any cation has 8 electrons outermost. Then see, don't draw. This we have already discussed in class 11, but many of you are not there, or anyone who is there also you forgot. See, cation, if it is small, as it is electron deficient, if you bring it near to an electron source, is obviously going to pull electron because it's a charged body. If you bring a magnet near to an iron, it's going to pull. So now, if the anion is small, that is, nucleus is very close to the valence shell. So even if it pulls, nucleus will not allow the electrons to be influenced by it. Nucleus will not allow to move for the movement of electrons because it is under its field. And when anion is large, when it comes near to it, what does it do? It pulls the electron in one side. By that, what I'm seeing, initially it is homogeneous. Now, when it pulls is there, you will find more electron will drift to this side. So what is going to happen now? See here. It will get now deformed. You will have now more electron in this side. And less electrons. That is, it is getting polarized. See, it is getting polarized. Now, as more and more attraction is there, what is going to happen now here? See here. This electron now cloud will penetrate the empty shell of cation. See now. What is going to happen now? See, overlap of the atomic or the valence shell has taken place. It was ionic, getting polarized. Overlap has taken place. It has attained a covalent character. Please remember, is applicable for any cation and anion if the size of the cation is small and the size of the anion is large. So electron cloud get polarized, anion electron cloud get polarized, and by that way it induces a covalent character in the of the salt. Because of that, you will find if you go to alkali metals, lithium chloride is alkali metals, halides are highly ionic. But if you go for lithium chloride, it is having some covalent character. So when you move from lithium fluoride is ionic, fluoride is very small atom, it cannot polarize the electron cloud. When you go to chloride, it's little bigger, polarization starts. If you go to lithium iodide here, iodide is very large. Lithium iodide is not soluble in water, soluble in organic solvent. Means what? Lithium iodide is more and more covalent. So it is not the question of the transition metals. It is not the question of the inner transition metals. It is applicable for all. So now, what do we say here? Basic strength. We know that inner transition elements have 14 elements. It starts from cerium, ends with lutetium. It is 3 plus and it is 3 plus. Say, due to lengthened contraction, lutetium has the smallest size. That is, it has the highest polarizing capacity. So please remember, lutetium hydroxide is more covalent. And if it is more covalent, if you put it in water, it is not going to ionize as much as the cerium hydroxide. So it will be less basic and it will be most basic. So what we can say? Due to lengthened contraction, the decrease of the ionic radii takes place from left to right, by which the basic character of the hydroxide decreases. Lutetium hydroxide is least basic because of the smallest size of lutetium. It polarizes the hydroxide anion and attains more covalent character. Right now here. Due to lengthanoid contraction, the ionic radii of Ln3 plus, I told you, no, the Ln is not an element, it is the abbreviated form of lanthanides. Ions decreases from cerium to from C3 plus to Lu3 plus. As a result, the covalent character of MOH bond increases. Hence, the basic strength of lutetium hydroxide, sorry, basic strength of lanthanoid hydroxide. Example, lutetium hydroxide is least basic, while cerium hydroxide is most basic.
Sir, can you please read out the last sentence? Hence the basic strength.
Hence, strength of hydroxides. Oh, sorry. Okay, I'll write it again. Hence, the basic strength of lanthanide hydroxide, sorry dear, decreases with increasing atomic number, or from left to right, or example, lutetium hydroxide is least basic. Within bracket we write what? More covalent. While cerium hydroxide is most basic. That is what we write now. More ion.
Done, sir.
Okay. Uses. Take care of this for exam. Use. See, please remember, abundance of lanthanoids on the earth crust is very, very less. Because of that, lanthanoids are also known as rare earth elements. While in case of actinoids, all of them are radioactive. So their utility is very, very less. So we'll go for the best use of lanthanoids is the production of alloys. Okay, now we are going to mention a alloy. Mish metal. Some book they write single L, some book they write double L. But to me it should be double L. Because this mish metal is word itself is a German word. So you by this one you know the meaning. Mish means mixture. Okay. In German spelling they make metal as double L. So it is up to you. If it is in your book, it is written single L, you write single L. If it is found in your book double L, then write double L. Right now, it consists of lanthanoid metal. They did not mention which metal. It contains 95% mixture also. Oh, sorry. Means equivalent. And iron. See, it is exactly not 5% or 95%. So, along with that, you have traces of other elements also. And traces of sulfur, carbon, calcium, and aluminium. Okay, now what for is being used? So right now, a large amount of mixed metal is used in magnesium based alloy to produce bullets, shells, means these are for cannon, and lighter flint. See, bullet should be very light, otherwise it will not fly in the air. Same is the case of shell. But it should be very hard so that it can go and penetrate in any other place. So, mesh metal adds a lot of strength and hardness to the alloy. And lighter flint. Lighter flint is that in the lighter, small stones are being used now. These are very light, but you will find you can use this one for 10,000 times. That is, their corrosion is very, very less. So this question often comes in your exam, and I found this very hot favorite in emboss, mesh metal. Okay, I'll take some more time. I'll go for actinoids, then this chapter finish. It is the series of 14 elements which occurs after actinium. It starts with thorium. I think 89 thorium. Yeah, 90. Sorry. Thorium. And ends with Lawrencium. Z is equal to 103. So what will be its electronic configuration? See here, this goes and this goes. Okay, now see here, as you have seen in lanthanides, they show +2 and +4, so it will also going to show. In addition to +3, these elements also can attain +2, +4, +5, +6, and plus 7 oxidation state. This is also important. Okay. So now we should see, in case of lanthanide is plus 2 and plus 4, why in this case so much? So let us see. See, lanthanide. Lanthanide is what? This is 6s. This is 5d. This is 4f. Here it is 7s. This is 6d. See, as you have lanthanide contraction, you also have an actinoid contraction. Okay? Because here also when you go on filling the protons, you feed the electron in the 5f orbitals. 5f orbitals are larger than 4f orbitals. So in that case, the screening is very, very poor. So it builds up more nuclear charge than that of the lanthanides. And so the contraction takes place. Please remember, actinide contractions is more than that of lanthanide contraction. Okay? So due to actinide contraction, see here, the energy gap between 7s, 6d and 5s, they're very close. So the electrons, first the 7s electron will go, then 6d will go, then after that 5f electrons also can go. So see here, if this is the one, this is for, this attains because of what? This attains because of 7s. Plus 3, why? Because when this electron also goes. And why plus 4, plus 4, plus 5, plus 6, plus 7, that is electron from the 5 also starts going. In this case, what happens here? A large gap exists between 4f and 5d. So the electrons of the 4f does not get enough energy to move it to the valence shell and participate in the chemical reaction. So it has limited oxidation state and it has more oxidation state. So please draw. After that I'll write down. So now we'll write. In actinoids, the energy gap between 5F and 60 and I will write here this end 7S is small. And hence the
Yes, sir.
see this 5F, see 6D and 7S they are very close. Here also 6S and 5D is very close. So I wanted to mean that the gap between this and these two. And hence the electrons of 5F orbitals can take part in bonding as a result. Exhibit larger number of oxidation states. In actinoid, in lanthanoids, a large energy difference exists between 4F and 5D orbitals. So 4F electron hardly participate in chemical reaction. and hence have limited oxidation numbers. Means what? +2, +3, and +4.
So they'll hardly participate in chemical reactions and hence have.
Limited oxidation number.
So you wrote limited.
And have limited oxidation number.
Done, sir.
Okay. Atomic and ionic radii. In the atomic and ionic M3 plus. No, I will not write here Ac, because actinium symbol itself is Ac. So we will write here now. Elements decreases with increasing atomic number or from left to right. Okay, again, why? This phenomenon is called actinoid contraction. Okay, so I shall note. Actinoid contraction is more than infinite contraction. Because of that, you will find actinoids are smaller than that of lanthanoids. Due to this, see, actinoids is below lanthanoids. Again, here should be bigger than that of lanthanoids, but no, actinoids are smaller. Due to this, sizes of actinoid elements or ions are smaller than corresponding lanthanoid elements or ions. So please remember, though actinoids lie below the lanthanoids, but sizes are smaller than that of the lanthanoids because of the stronger actinoid contraction. Control X. Control C. Control D. Control C, control D. যাচ্ছে তুই জমা দিচ্ছিস ইনভেস্টরটা তোর অ্যাকাউন্টে যাচ্ছে না তোর অ্যাকাউন্ট ডেবিট হয় কোন অ্যাকাউন্ট থেকে চলে যাচ্ছে ভগবান জানে color of ions. They have unpaired electrons. ऐसा सब नहीं पड़ेगा
Sir, FF transition.
Yes.
The spelling, sir. Done, sir.
See, this is completely filled, no question of transition. This is no electron, no transition. But why in this case? Because it is stable. Because of that, electronic excitation does not take place.
Done, sir.
Magnetic properties. In magnetic property, there cannot be any excitations. Okay. Lanthanides do not form so many complexes, but actinide forms. Again, because of its small size. don't remember where we left off. Yeah. So we had landing page, so we had developed lower. So in this sheet, it is not exactly the same, but you will see that the breakdown will be different. So you see content in market, URL 30, south, main, and there you will see also this because south, yeah, intent in market. So can you see seller is there? If seller is mentioned, seller is not mentioned. Can you go back to okay? Wait. Okay, so you see now very simple to understand. Seller benefit are the types of so every if you looking at the using parameter, you need to define it here. Right? You can practice over different units. So let it be that.
See here. Lengthener is also 3 plus, actinoid is also 3 plus. But the radius of actinoids are smaller than that of lengthener, so the ratio is more.
So I think what I'm trying to say is you have to
Higher turbo radius ratio.
market to break it down, there is market to compare URLs, we compare URLs, out with out. So can you be a situation where the trafficker needs to enter the mapping? That at the intent, maybe because customer intent will not be intent. URLs to URLs, because in the future, if we see that seller is mentioned to the UCN as well, the software cannot be so smart as to figure it out itself. So maybe input mapping practically कर देगा कि ये field profession and field doesn't. Does that mean?
This for entrance.
We have to be also have to take the UCN. Right? Now, how do you take the UCN here? Because it's not exactly the same. Right? But you can map the field. So in market, it's basically the software should say that the absolute in-market is present, UR is present, south is present, mail is present, right? Okay. Now, if you look at the
one number to 19080 the last
also,
number.
right? So they can scale for 250, this may not be there. Sell it in the future. Because a different team needs the user back. They may have a requirement to make sellers be there. So today you have created a app which compares for 4 parameters. More than 5. How will the app? If the trafficker says that compare 4 feeds with taken 4 feeds in landing page, click on OK. Then the process. Then it will take whether the landing page is correctly and if there is an error, it is. Does that make sense? I think in the picture to हाँ मतलब मैपिंग कर देगा जैसे डॉक्टर बोल रहे हैं कि साउथ मतलब जियो साउथ टू मैप टू साउथ on C1 is not required intent to map to that intent because ये हो गया non C1 हो गया उनका cohort फिर intent हो गया intent भी cohort है sorry in market की intent in market नहीं है mail को mail के साथ मैप करो मतलब जनरल मैप कर लो और static जरूरत भी नहीं है
Because the reaction of oxygen. And done. They are highly reactive. In order form. They do not react with alkalis. I don't know whether in your textbook so much thing is there or not, but you should know. So with this, I finish D and F block. So tomorrow being a holiday of Tagun Sama, I think we have some other holidays also we observe. So tomorrow morning I will not take that class. Next week I shall start with coding and chemistry. Okay, good night.
Thank you.